Today we're going to show how to create minimum distance constraints in a Fusion 360 sketch. The first thing that we're going to do is we're going to create a new sketch. And in that sketch, we're just going to create ourselves a couple objects that we can enforce the distance between. In this case, I'm just using 20 millimeter circles. And then I'm going to, sketch out a line that shows us the distance between the centers of those circles. Unfortunately, there is no built-in minimum distance constraint. And so it would be nice if we could just check that, and then, when I move this circle around, when one gets too close to the other, it should push the other away. That's the theory that we're going for. So what we're going to do is we're going to create some geometry that's going to enforce that for us. And over on the right here, this geometry that I'm creating is a ruler that's going to mirror the distance between the two circles. So that horizontal line is our 0 point, creating a second line the vertical line, 0 point, creating a second line that is our 50 millimeter point away. Then I'm going to make these two construction lines be equal to each other so that as we move the circle and the distance between the circles change, the line on the right is going to always maintain the same distance as the line between the two circles. Now, we're going to create that geometry that enforces that we always have a minimum of 50 millimeter distance between the two circles. So I'm going to use a circle for this, and I'm going to make it tangent to our limit line, that 50 millimeters, and then I'm going to make the end point of our distance measurement line coincident on that circle. Now you'll notice that that's already doing more or less what we need to do, but just for thoroughness, I like to create a second line that's a little bit to the right of the first line, and then I put a point on that and make sure that that point is also coincident on the circle. That enforces that the circle stays to the right of our minimum distance line and doesn't flip around to the left and suddenly become a maximum distance line. So if you wanted to create a maximum distance line, you could actually use the same technique and just make sure that the circle is on the left of your limit line. Now here, let's show a way that we can use this to actually keep at least one of these circles inside of another piece of geometry, in this case, a rectangle. So what I've done is I've dropped lines from the center of the circle that we want to contain to the outer perimeters of each of the four sides of this rectangle. And then I'm going to create lines on our ruler, that construction over on the right, that mirror each of those four distance lines. Notice I'm using the equals constraints to create that mirror here, right? So each one of these is going to represent one of those perpendiculars that we dropped. And then I'm going to use the same sort of technique here. Now here, I'm going to set the minimum distance to the radius of our circle. So our circles are 20 millimeters long, so I want that circle center point to never come less than 10 millimeters away from the edges of one of the edges of our rectangle. And again, I'm using that same sort of technique of dropping a second line to the right of the first one, putting a point on that, and then I'm going to make that point coincident on our circle along with all of our four other endpoints of our measurements. So again, we create that tangent between our 10 millimeter limit and the circle. We create that coincident point to keep the circle on the right. And then we take the endpoints of those four measurement lines and we put them coincident on the circle as well. Notice that that shrunk our rectangle because we didn't have any constraints on the size or position of that rectangle. So I'm going to go ahead and make that rectangle stay relative to the origin, and I'm going to dimension it out to, let's say, 100 millimeters on a side. Now I think this should be enough that we can grab our circles and move them around. They'll always stay 50 millimeters away from each other on center, and if they try to get too close, one will push the other, and the one that's inside of the rectangle will always stay inside of the rectangle. Notice that the constraints force my cursor to kind of jump back and reset if I try to go outside of those limits. And that's all we've got to do. That ends our tutorial for creating a minimum distance constraint in Fusion 360.